Okay, folks, I am in the home stretch of videos for this week. I hope that you're actually not watching this video until you've had plenty of time to really think through lessons 1.9 and 110. If you're trying to do all this in one day, it's probably just going to be too much. It's actually too much to do videos for. My brain is about fried. But here is my deal to you. On page 44 and 45, you have 54 problems, and these 54 problems are going to be counted as your test grade. You only have two lessons to do, 1.9 and 1.10, and then you have this review of algebraic basics, and that's going to be your test grade. I want you to do well, and I, more importantly, want you to understand what it is that you're actually doing. So bear with me. We're going to go through a lot, and if it takes you 2 separate days to complete all of this, then just so be it. Go at your own pace, and if it becomes too much, just hit pause and come back to it on the next day. You just have to have it all in by midnight next Saturday, like August the 31st. Okay, so what I'm going to do is I am going to actually walk through several of your problems. So you're going to leave listening to this video with a whole bunch of free answers for your test. So that's my gift to you, is that if you're willing to walk through the test with me, then you're going to get free answers by me. I'm going to go ahead and just start with number one. So I'm on the test, okay? I'm on page 44 and 45, and number one says, evaluate each expression if A equals 3, B equals a negative 2, and C equals 2. Okay, some of you are not very neat. Please be neat. It will make your life easier and my life easier as well. So I have A and this little tiny c up here. So it's raised to the c power plus b. So all I have to do is drop in the values of a, b, and c, and then just solve. So I'm going to just completely replace this 3. This a is going to become a 3. This c is going to become a 2. Copy down my plus sign. And this b is going to become a negative 2. So since I'm going to have a plus and then a negative 2, it just makes sense to go ahead and use that algebraic arithmetic model and put that into parentheses. So in order to solve this, I'm going to use my please excuse my dear Aunt Sally. And there's nothing to be done inside this parentheses. So I don't really have anything there to do. The next thing I need to do is my exponent. And that exponent says 3 times 3, and 3 times 3 is 9, plus a negative 2. So I have a positive 9, and I'm combining it or adding it to a negative 2, which is the same as saying 9 minus 2. And my final answer for number 1 is going to be 7. Now I'm going to let you pause the video, and I want you to do 2, 3, and 4 by yourself. And then when you're finished, hit play again, and I'll be on number 5, and we'll just keep moving through the assessment together. Pause me. Okay, I'm back. Thank you for unpausing me. So number 5 all the way through 34, the directions say simplify each expression. And I'm just going to keep moving. I'm going to solve several of these for you with you pausing along the way to do the other ones that are kind of similar to what I solve. And I'm literally just copying down the problem here so that then I can work through each step and talk you through what I did to solve it correctly. And this is squared. It's ugly parentheses, my bad. So please excuse my dear Aunt Sally. I love it when I'm grading your homework and I see that you've written PEMDAS down on your paper. Makes me super happy. So the very first thing I need to do is parentheses, and I have 2 of them. And I have the green light to go ahead and solve them both at the same time if I want to, because they're in 2 different entities of the problem, like 2 different terms. So I can solve them at the same time. It's not going to cause any problem. If they were like really close to each other, I would say just solve them one at a time. But since they're far apart, it's fine. So I'm going to have a 5, a parentheses. 9 minus 4 obviously is 5. Copy down my plus sign, my 3. 6 plus 2 is 8. Going to keep that in parentheses and then copy down my squared. So I'm finished with parentheses because really there's nothing left to do here. There's nothing left to do in this one. There's nothing left to do in this one. I've now moved on to exponents, and I have an exponent. 8 times 8. That's what this says. This says 8 times 8. And 8 times 8 is 64. I literally double checked myself on my calculator. No shame in that game. Wanted to make sure I was doing it right. Okay, so I'm going to just copy down my 5 in parentheses, my plus, my 3, and now I'm going to replace 8 squared with 64. Okay, I have some multiplication and I have an addition in the middle. Now we know that we do multiplication from left to right. So I can do them both at the same time or I can do them separately. I'm going to do them separately for the sake of just explaining to you what I do. 5 times 5 is 25. Copy down my plus, copy down my 3, copy down my 64 that's in parentheses. And remember, we know that when we have something in parentheses, it means multiply by. So my 64 times 3, again, no shame in my game because it's 192. And copy down my plus sign and my 25. And I can go ahead and just punch 25 into my calculations. I already have my 192 in, and it gives me a total of 217. So that is the answer for number 5. It's 217, and hopefully you can see the order of the operations that I used to solve this problem. So I'm going to turn you loose and let you go all the way through number 13. And I'm going to meet you back. You hit pause, solve 6, 7, 8, 9, 10, 11, 12, 13. And then when you get ready to solve 14, come back to me and I will solve number 14. Okay, if you didn't hit pause and you're just still listening to me, then you know I'm on 14. Or hopefully you have now finished all the way through 13 and you're ready to solve 14 with me. That's ugly. So let's just go ahead and change colors while we're at it. I have 4 plus a negative 2 plus a 3 plus a negative 5. Now, this problem is already set up in an algebraic arithmetic situation. I have all my negatives are clumped together in parentheses, and I still want to refer to my please excuse my dear Aunt Sally because you guys might not see what's actually happening here. And I could say, okay, I got to start with parentheses, and then I could go, well, I've got a parenthesis here and I have a parenthesis here, but there's nothing I need to do, so I don't need to do anything. And so I'm good here. And then I can go on to exponents, and there's no exponents, so I'm good here. And I can go on to multiplication, and no, like I totally just have an addition, an addition, an addition. I mean, I've got some negative numbers, but like I'm done with multiplication, I'm done with the division, and I'm basically here. Okay, so I have a couple of choices. I can just go left or right here and kind of use my brain and my timeline and say, okay, positive 4, take away 2 is going to leave me with 2. Okay, 4 plus a negative 2 is 2. Plus 3 is 5. And then plus a negative 5 is going to be 0. I could have done it that way, and then obviously my answer is 0. But some of you like to combine up things, which there's nothing wrong with it. I have a negative 2 and a negative 5, so I could sort of put those together first. A negative 2 and a negative 5 would combine for a negative 7. Okay, and then I have a 4 and a 3. Let's just grab a green here. I have a 4 and a 3. Those are my positive numbers, and they would combine for a positive 7. So I could say a positive 7 added to a negative 7 will also give me a 0. But as long as you come up with that the answer is 0 because you used algebraic arithmetic and combined your like entities, your negatives and your positives, you're in good business. So I'm going to just go right on in and work number 15 for you as well. So you didn't have to hit pause that time. You're just going to get 2 free ones back to back. Okay, number 15 says negative 7. Then there's a bracket. and then there's a 3, and then there's a 6 minus 8. If you don't understand this problem when I'm done with it, when I was reviewing, I think 1.7, I did a problem almost just like this. So if it doesn't make sense, go watch that one. Please excuse my dear Aunt Sally, and it can help reinforce this problem. So I have to start with parentheses. I've got a bracket here, and I've also got a smaller parenthesis, and we always say we have to start inside out. So we're just going to start with 6 minus 8. Oh, goodness, 6 minus 8. It's 6 minus 8 is not complicated. 6 minus 8 is just a negative 2. Hopefully that is not overwhelming for you. So 6, if I'm on a number line and I need to go negative 8, then I'm going to cross over 0 and I'm going to end up with negative 2. Now I'm just copying everything out here to make sure I have it all. Okay, so I still have this parentheses, so I'm not finished with my P step because this is all still one big parentheses. And what it says is 3 times negative 2. That's what it says, 3 times negative 2. Well, we know that anytime there's a positive, which there's nothing here, there's no sign, so it's an assumed positive. A positive and a negative gives us a negative, and 3 times 2 gives us 6. And I'm just going to keep it in parentheses. I could have kept it in brackets if I wanted to. It didn't matter. I'm going to copy down my negative 7. Now, I have a negative 7 and then negative 6 in parentheses. This is a multiplication step. I've finished my parentheses. I'm really done with parentheses because there's nothing to be accomplished in here. We've got it cleaned up. So my parentheses are finished. There are no exponents, so that's finished. And I'm here. I'm at multiplication. I basically have this situation where I have negative 7 times negative 6 because that parentheses next to it tells me that it's a times. And when I have a negative times a negative, I have a positive. Okay, so it's going to be a positive number. And 7 times 6 is 42. So it's positive 42, which you can just write as a 42. And that's your answer for number 15. So 16 is very similar, except for there's a squared there. So when you're narrowing it down, make sure you pay attention to the square root. And honestly, it's kind of similar all the way through 17 and 18. I'm going to meet you back. I want you to pause the video and then come back and meet me for number 19. Hopefully you're back now for number 19 and you found the rest of those problems in the middle to be successful. I'm going to work number 19. I'm just copying down what I have here. And I really, truly hope that you're pausing me and going in order because it is definitely the best way to tackle this. You can tell that these problems are building in complexity. And obviously number 34 is more complicated than number 7. And so if you will solve these problems in order of complexity as I solve them, and as we're having to utilize more math sense, then you're going to have an easier time at solving these problems. Okay, please excuse my dear Aunt Sally. Okay, so let's see what we can do to solve this problem. I've got 3 sets of parentheses, but they don't need anything done to them, so there's nothing to do here. There are no exponents, so I can skip this one. So I'm on this multiplication and division step. And remember, multiplication and division is left to right. I don't see any division, so I probably don't need it, but let's just go ahead and figure this out. Okay, right here, I have the negative sign outside of a negative 4 in parentheses. Now remember, this is an assumed negative 1. So I basically have this situation right here that says negative 1 times a negative 4. And 4 times 1 is 4, and negative times negative is a positive, so all that turns into a positive 4. Now, I have the same scenario happening here, and because I have the property, the associative, is it associative? Yes, it's the associative property of multiplication. I can literally multiply these in any order, but I'm a left to right kind of gal. So all I'm going to do is multiply negative 1 times negative 2. This right here says negative 1 times negative 2. And negative 1 times negative 2 is a positive 2. Negative 1 times negative 2 is a positive 2. I still can just copy down my parentheses and my negative 3. I hope I didn't do too much there and confuse you. I am still on my multiplication step. So I have a multiplication problem right here. I have a positive 2 and a negative 3. So positive 2 times negative 3 is a negative 6. So I'm just going to copy everything else down. Oh, that's a crazy looking plus sign. Plus 4. Okay, so I am to my final steps. I have addition and subtraction. I have to go left to right. That's all I have left. So I'm going to start here with the 4. 4 plus 6 is 10. Minus 6 is 4. So for number 19, my final answer is 4. I'm going to jump in here just to be like a crazy person. I could have rewrote this stuff right here to make it look more like the algebraic addition. And if I did, it would be 4 plus 6 plus a negative 6. So if I would have kept this parenthesis and said this was a negative 6, then I would have kept this, I would have just brought down my plus sign here, and this is what that would look like. But it doesn't matter because it still all ends up at 4 as my final answer. So I'm going to leave you to do 20, 21, 22. I'm going to let you do 23 and 24 all by yourselves. I don't think that you're going to have any problem with 25 or 26. So you need to work all the way through number 26, and I will meet you back with number 27. Pause me and come back to me. Okay, here's problem number 27. So it says 7n plus 6n minus 9n, this is forever long, minus 6n plus 3n minus a regular n. Oh, let me turn that into an n. I drew a 1 there because I wanted to say it was 1 n. I was like thinking and writing it all at the same time. Plus 4n minus n. Whew, goodness gracious. So all of these numbers, okay, even like right here, there's an invisible 1, and right here, there's an invisible 1. They're just whatever the number is, plus or multiply by n. Well, I don't know what n is, so n's going to stick around through the whole collection of what I'm doing here. The best, if you could do it in your mind and just keep it rolling and be able to do it like in a number line way, this is how you could do it. Okay, 7 and 6 is 7 plus 6 is 13. So I could just like copy down minus 9 minus 6 plus 3 minus 1. Notice I'm dropping my n's just for simplicity right now. Plus 4 minus 1. So 13 minus 9 is going to give me obviously a 4. Yes, I double checked it. Minus 6, it's late. Plus 3 minus 1 plus 4 minus 1. Okay, 4 and a negative 6 is a negative 2 plus 3 minus 1 plus 4 minus 1. I'm just trying to show you all the steps that you could take. Negative 2 and a 3 is a 1 minus 1 plus 4. Oh, minus 1. Yikes, I forgot it up here. Neatness is key, people, even for me. 1 minus 1 is 0 plus 4 minus 1. So this is a 4 minus 1. And hopefully my final answer, yes, is a 3. But I can't forget my n, okay? All of this had an n to begin with. So my final answer is actually 3 times n. Okay, I just removed the n so that you could see all the numeric coefficients that were tied to the variable. And I just put n back at the end of it. Hopefully that didn't confuse you. Now, so there's another way I could do it, like always. So let me just, if you are an addition of the opposite person, yeah, if you like the algebraic addition, then you're going to want to start by totally just rewriting this dude. So you're going to say 7n plus 6n plus a negative 9n plus a negative 6n, and it's okay if you like to do it this way, plus a 3n plus a negative I'm going to just go ahead and say 1n so that we're all on the same page here. It doesn't confuse you. You're rewriting it anyways. You might as well throw in your 1s. Plus a 4n. You notice I'm not doing anything with my pluses. I'm just dropping them in. I don't have to do anything to them. I'm just only putting my negatives in parentheses. Now, you're to the point where you would combine like terms. So what's alike here? Well, all the positives are definitely alike. So I'm just looking through and underline it. So basically what I have for my positives is 7 plus 6 plus 3 plus 4. So you go 7 plus 6 plus 3 plus 4, and you end up with 20. So I would have 20 in, okay, plus. Now I'm going to do the exact same thing. I'm going to combine all of my negatives. So here's all my negatives. So this would be the same as 9 plus 6 plus 1 plus 1. So we're talking 17. Yeah, we're talking 17 here. So then I would have a negative 17 in. And you might be like, well, wait a minute, you just said positive. I just took the numbers. See, the 9, the 6, the 1, and the 1. They're all negative. I knew that. I could have said negative 9, negative 6, negative 1, negative 1. I would have had a negative 16. I was just trying to make it more simple. So now I have to combine a positive 20, a 20 in, and plus a negative 17 in, which is going to end up with a 3 in, because 20 minus 17 is 3. So there's two different ways that you can solve number 27. It's just whatever, it's personal preference. I'm going to turn you loose. I'm going to let you do, oh, I tell you what, I should probably do 28 with you. So I'm going to do 28 with you. But I really want you to pay attention, because the same technique, the distributive property that I use in 28, you're going to be using, it looks like, for most of the rest of these problems. Maybe you don't have to use it on 33, but the other ones you do. So for 28, it's 3 times A plus B. I'm going to be using that distributive property to do some jailbreaking here. Plus, actually, I'm going to teach you a shorter method. I'm going to teach you both. Plus A plus B minus 4A plus B minus A plus B. Okay, I'm cheating over here and looking at the way Abeka wants you to give this answer. Okay, so if you were doing the algebraic addition version of this problem, then maybe you would realize off the bat that A plus B is the similar unknown here. And maybe you would say, okay, let me just find all my coefficients. Here's a 3. Here's my invisible 1. Here's a negative 4. And here's an invisible negative 1. So kind of a shortcut way that I could do this would be to combine all these coefficients. 3 plus 1 minus 4 minus 1. Okay, 3 plus 1 is obviously 4. Minus 4 is 0. Minus 1 is a negative 1. So I have a negative 1 as my coefficient. So with that being said, I could just put a negative 1 coefficient and then go ahead and put my unknown, which has been consistent all the way throughout. So I would just put times whatever in the world A plus B is. Well, now I need to distribute, and I can't get rid of A plus B any other way, because who knows what A and B is. But I do have this negative 1 right here, so I'm just going to distribute it. Negative 1 times a positive A is a negative A. And negative 1 times a positive B is a negative B. And that is the shortest way to come up with this answer. Okay, I'm going to totally clear it out, and I'm going to show you the other way that you could have solved it. Okay, the other way that you could solve this problem, number 28, is by just using the distributive property everywhere. And I want to show you this one because it's a great problem to practice the distributive property, and you're going to need it for some other problems. So let's just go ahead and solve it both ways. Hopefully you're hanging in with me in this really long video. And I'm just copying everything down. Okay, so if I'm going to distribute this out, then I'm going to have to let's just roll. Okay, I can't do anything plus a plus b, for a plus b inside the parentheses. I don't have any exponents or anything that I need to deal with, so I'm just going to distribute. So 3 times a is 3a. 3 times b, a positive 3 and a positive b is a positive 3b. Okay, this is like a invisible 1. So a positive 1 and a positive b is just plus 1a. A positive 1 and a positive b is plus 1b. Hopefully I didn't say that wrong. I'm going to distribute this. A negative 4 to a positive a is a negative 4a. A negative 4 to a positive b is a negative 4b. And the last one, here's my invisible 1 again. So a negative 1 to a positive a is a negative a. And a negative 1 to a positive b is a negative b. Now I can do some like terms. I can find, and here's a, and a. So I have essentially 3 plus 1 minus 4 minus 1. Hopefully you can see that. My 3, my 1, my 4, and this is the same as saying 1a and 1b, and my 1. So 3 plus 4 is 1, minus 4 is 0, plus 1 gives me a negative 1a. So I have a negative 1a if I combine all my a's. If I do my b's, I have all these b's. So I have a 3 plus 1 minus 4 minus 1. 3 plus 1 is 4 minus 4 equals a negative 1b. So I end up with a total of negative 1a plus negative 1b, which is just the same as a negative a minus b. So that's the way that you could do that problem. You could go either way. Okay, so I'm going to end there. If you have paid attention to all of my review videos, then you shouldn't have any problem doing the remainder of these problems. I know I'm leaving you with the more complicated ones, but I want you to see if you can do them on your own. I have a lot of faith that you can. I am going to stop the video right here, and then I'm going to come back and make a secondary video for the review problems for 35 through 54, just so that if you need to stop now, if your brain is mush and you need to stop after solving number 34, then you can do so and have a second video to start with. Okay, see you again.